Okay, so for section 8.1, part 2, we're going to be working with the law of cosines. So part 1 was law of sines, part 2 is going to be law of cosines. So these are the equations for the law of cosines. The law of cosines, so again, these are triangles that are not 90-degree triangles. And if we were going to show you the proof of it, which I'm not going to go through the whole proof, but what we do is we would do the same. We would drop down a height and make two 90-degree triangles. And then down here we would have to call this x and c minus x. Then we would go through and use the Pythagorean theorem and then FOIL all of that out, multiply it all out, everything. We will end up with this information over here eventually. A few things in there that you'd still need to do, but that's kind of the gist of it. Also, the other thing I want you to realize too is if we put in the cosine of 90 degrees, so let's say that A was a 90-degree angle right here. So let's say right here. So we pull down a line, and then let's call that angle A right here. That's a 90-degree angle. Well, what is the cosine of 90 degrees? Cosine of 90 degrees is 0. So if the cosine of 90 degrees is 0, that's going to block out all of this extra stuff that's tacked on. So the law of cosines actually proves our Pythagorean theorem. And so it's just an extended version of the Pythagorean theorem. If you're using it with a right triangle, this last part doesn't come up. But if you're using it with something other than a 90-degree angle, then we need all of this other information. So memorizing these, or just make sure you write them down somewhere, and once you use them a few times you'll get the gist of it. But it's pretty much a squared equals c squared plus b squared, so that's all three sides. Okay, and then the side that's on the left hand side of the equal sign is the same, or the opposite, the pair of the cosine angle that we're using. Okay, so if we have where's my tip at? Alright, so if we've got this a squared on the left-hand side of the equal sign, then it's going to be the cosine of angle A that we take. Then if we go down to the next one, notice it's b squared that's on the left-hand side of the equal sign. Well, then it's cosine of b that is on the right-hand side. So notice that those are always paired together. We've always got a squared here, angle A here. B squared here, angle B here. C squared here, angle C here. And then what's here in the middle is everything else. So if we have c squared on the left hand side, then we're going to add the sum of the squares of the other two sides minus 2 times the other two sides, and then cosine of the angle opposite the side on the left hand side. So it's really not too difficult of an equation to memorize. I'm not too worried about that. Just as long as you can figure out how it works, you'll know how to use it again. You don't have to memorize that equation. All right, so let's look at example number 1. So example number 1, given the triangle here, so we've got, why is my pen not working? I'm going to have to pause for a second till I get my pen going. Okay, I think we're good now. All right, so here we're given the degree of 55, and then we're given two sides. And we want to know what x is. So x is opposite of the angle given, so that's good. So I'm going to start off with x squared because it's going to pair up with the angle at the very end. So I'm going to start off with x squared, and then that equals the other two sides squared, doesn't matter the order, minus 2 times those other two sides that we just wrote down, times cosine of the angle opposite of the first side that we started with, in this case 55 degrees. So we go through all of that, figure out all of that on the right hand side of your equation with your calculator. You should end up getting 0.3, nope, sorry, I'm the wrong one, 509.296, and then don't forget to take the square root of both sides. So take the square root of both sides. Since we're working with lengths, we don't have to worry about that negative. So the square root of 509.296 is going to be 22.568. And that's what x is. And that's all. We're done with that one. Okay, example number 2. This time we're given all three sides. So again, we can use the law of cosines for this. The angle A is the side that we want to find. And so I'm going to start off with this side 18. So 18 squared equals the other two sides squared. So 18 squared plus 14 squared minus 2 times 18 times 14 times cosine of A. And so now we're going to have to solve for cosine of A. So be really careful on this part. So we need to simplify. We can do 18 squared. Let's go ahead and do 18 squared there. So 18 squared is 324. And then let's go ahead and add these two. So 18 squared plus 14 squared was 520. And then I multiplied all of these together, and we get minus 504 cosine of A. Okay, remember these are being multiplied together, so don't do 520 minus 504. Just be really careful, don't make that mistake. Now I'm going to subtract 520 from both sides. And we get negative 196 is equal to negative 504 times cosine of A. Divide both sides by negative 504. So just be careful on this one of trying to do too many things or trying to skip steps. It's really easy to make just a few algebra mistakes in there that are going to throw you way off. So we end up with a cosine of A is equal to 0.388889. And take the arc cosine of that, make sure that you're in degrees, and the arc cosine of that is going to be 67.115 degrees. And then you're done. All right, example number 3. Find C if A equals 2.88 miles, B equals 3.68 miles, and the angle of C equals 41.7 degrees. So again, we're given two sides and an angle. However, this angle is, if we looked at our triangle, let's say this is angle C, A, B, so B would be over here, side B would be 3.68, side A would be 2.88. So the information that we are given here is an angle, a side angle side. A side angle side. So that is one of the forms that we have to use the law of cosines for. So what do we need to find? We want to find what side C equals. So we're given these two sides, so we're going to start off with little c squared is equal to 2.88 squared plus 3.68 squared. So we have c squared equals the other two sides squared minus 2 times the other two sides again, and then 3.68, and then cosine of side C, which is 41.7 degrees. Okay, and then again, go through, solve. You can put all of that into your calculator. Just make sure you get all your operations correct, but you should be able to do it all in one time. And then you get c squared equals 6.010. Take the square root of both sides, don't forget that one, and then 2.452 will be your final answer for that, 2.452 miles. Okay, moving on to example number 4. Is given the triangle the sides 39, 11, and 31. We want to find the area of the triangle and round your final answer to 4 decimal places. Okay, so we want to find the area of this triangle. Well, we know that our equation for area is area equals 1/2 times the base times the height. Well, we know what the base is. We just need to know what this height is. Okay. Well, if we just had one angle, let's say if we had this angle right here, we'd be able to use the sine of that angle over, let's call that x, which is the height, x over 39. That would be great, but we don't have the x and we don't have the angle. But using the law of cosines, we can easily find that angle. So let's say we have 11 squared is equal to the other two sides squared minus 2 times the other two sides again. So 39 and 11, 31, sorry. And then cosine of the one that we're missing. So let's call it C. Okay, so cosine of C. So now we need to go ahead and solve for C. So go through all of the math of that. Let's see how much I've gotten written down here. So 39 squared plus 31 squared, or 39 squared was 1521 plus 961 minus 2418 cosine of C. Then I added these two together. I got 2482. And then subtract that 2482 from both sides. And then you should have negative 2361 equals negative 2418 cosine of C. And then divide both sides by that negative 2418. And then I had the cosine of C is equal to 12. No, I didn't write down my decimal, that's why. Well, I just had the cosine of 2361 over 2418. And they take our cosine of that, and you should end up with C equals 12.465 degrees. So that answer right there is what we can put in for that angle. So that angle equals 12.465 degrees. Now that we know that angle, we can just use our regular trig function sine, and we know that sine of 12.465 degrees is going to be equal to our opposite, which that has to be a 90-degree angle when we use a 90-degree triangle when we use these. So only because we have that height in here can we do that. And so the opposite is now the x value. So x over 39. And so 39 sine of 12.465 equals x. And put that into your calculator, and you will get x equals 8.418. Now, that tells us the height of our triangle. So now we can go back to our equation and actually find the area. So our area is equal to 1/2 times the base, which is 31, times the height, which is 8.418. Multiplying all of that together, you will get the total area of your triangle is 130.481. And that's the angle, how you find your area of your triangle if you're given 3 sides and it is not a right triangle. Okay, example 5. Okay, example 5, this should look familiar. This was also in part 1. The only difference now is, notice that they're giving you this angle out here, angle C. In the last equation, or last problem, they were giving us angle A. So now we have side angle side, and we're going to have to use that law of cosine to figure out what our side C is. But it is opposite side of side C, so that is helpful. So we have C squared, which is the side that we want, is equal to 1.37 squared plus 2.61 squared minus 2 times those two sides again, times the cosine of 34.5 degrees. So enter all of that into your calculator. I'm going to pause here just for a second because I have not calculated all of this and I'm about out of time. Okay, so I got C squared is equal to 2.795, and then take the square root of both sides, and we end up with C is equal to 1.672, and that's in miles across the lake. All right, and so that's all for our first video.